Welcome to EDU World Space.
So in this question, we have to find the maximum kinetic energy of electrons ejected from barium with the work function 2.48 electron volt when it is illuminated by white light. So we know that the photon of visible light with maximum energy has the minimum wavelength. So we took the minimum to be, we took the wavelength here to be the minimum wavelength of white light, which is 400 nanometer. Now we use equation 27.5b from the textbook to calculate the maximum kinetic energy. Now this equation says that h times f, or the energy of a photon, is equal to the work function of the metal plus the kinetic energy. Now since we want the maximum kinetic energy, so this will be equal to h times f minus the work function. Now work function for a metal is a constant. Now since we want the maximum kinetic energy, so this should be maximum in order for this whole thing to be maximum. So for this region, we are taking our wavelength to be the minimum value. Now we know that, so let's write this. We don't need the bracket here because h is basically a constant, so our frequency should be maximum here. So now maximum frequency is c, or the speed of light over the minimum wavelength, minus the work function w naught. Now before doing the calculation, we need to see that h, or the Planck constant, is 6.63 times 10 to the power minus 34 joules per second, and c is equal to 3 times 10 to the power 8 meter per second. So when we calculate hc over lambda min, we will get this value in terms of the units of joules. But the work function we have is an electron volt. So we need to make sure that we convert this from joules to electron volt when we do the whole calculation. So let's do it now. So h is 6 times 63 times 10 to the power minus 34 joules per second. C is the speed of light, which is 3 times 10 to the power 8 meter per second. Lambda minimum is 400 nanometer, or 400 times 10 to the power minus 19, minus 9 meter. So this is in joule, and let me write it in red. And 1 electron volt correspond to 1.6 times 10 to the power minus 19 joules. So this much joules then correspond to, we can simply divide it by this number, 1.6 times 10 to the power minus 19 joules over electron volt, to convert this into electron volt, minus W naught, which is 2.48 electron volt. Now we can then solve this whole equation, and we get K maximum to be 0.68 electron volt.